We are the NAV H1 Drive Fluid Test Stand for Naval Air Systems Command. Our team members include Taylor Brady, Clark Lyons, Kyle McClellan, Alex McIntyre, Josh Stauffer, Maggie Talley, and Ethan Watchrood. Our faculty mentor is Dr. Bamdad Lasani. Naval Air Systems Command is a defense contractor that manages the marine aircraft, such as the H-1 Huey helicopter. These helicopters are susceptible to corrosion within their rotor gearbox. To mitigate this, NavAir has designed a magnetic accumulator that will be used to measure the metallic contaminants within the drive fluid of the helicopter. Our team has been tasked with designing a test stand that will simulate the drive fluid operational conditions of the rotor gearbox in the H-1 Huey helicopter. The test stand is required to be easily movable by 2 or fewer people. It must have a flow rate of 1 to 3 gallons per minute at 0 to 2 psi and mimic the viscosity of the oil in the rotor gearbox. The team was supplied a pump by NavAir and used a variable frequency drive to convert 240 volt single phase power to 3-phase and design a system that would control the speed of the pump.
The design overview begins with the heated main reservoir. It is then sent to the pump via 1-inch piping at 3 gallons per minute. The variable frequency drive is what controls the speed of the pump. An agitation line is then introduced into the system to stir the particle contaminants within the main reservoir. A step down from 1-inch to 1/4 inch occurs. Pressure gauges are located before and after the pump and also before the magnetic accumulator. The accumulator is placed in the 1/4 inch line and has a flow control valve to help achieve the required pressure and flow per minute. The flow then returns to the second reservoir, and the 10th item is the drum temperature controller used to control the heated main reservoir.
The first step in validation testing was to fill the barrels with oil to ensure there were no leaks in the fluid system. We confirmed that the controller and the heating wrap worked together. The VFD was then turned on to gradually adjust the flow rate through the fluid system. The flow control valve before the accumulator was then adjusted to reach the critical pressure for the system. Once the desired flow rates and pressures were achieved, the metal contaminant particles were then added into the fluid system. We then tested the capture efficiency of the magnetic accumulator by extracting oil from each reservoir and comparing contaminant levels in each.
Future design improvements include an addition of a fluid mixer to eliminate the agitation line, putting a flow control valve on the agitation line, or using a smaller pump to allow for higher pumping efficiency.